Hey guys, HackerSploit here, back again with another video. Welcome back to the Penetration Testing Bootcamp. In this video, we're going to be talking about scan timing and performance with Nmap. Now, in the previous video, we touched upon firewall evasion and we took a look at all the various techniques that you can use with Nmap to evade firewalls. And in that video, I touched upon a very important element, and that is the fact that you can use the various scan timing and performance techniques with Nmap to also avoid firewalls and intrusion detection systems. So the purpose of this video is to highlight that, and we'll also be taking a look at the use of scan timing and performance options to increase or to speed up or slow down scans. All right, so Nmap by default allows you to speed up and slow down scans based on the type of environment you're working in or the type of environment that you're targeting. You know, again, you could be targeting an entire network or a particular host that is set up in a specific way. It could they could be having some rate limiting in place, or you could be performing scans on a network that has very old hardware and is susceptible to crashing. Right, so this is very important as you may be dealing with network or business critical infrastructure that, again, as I said, will not be able to handle heavy or noisy scans. On the other hand, you might you maybe want to speed up your scans when you're performing large types of scans on entire subnets or class B and C networks. And of course, as I said, you can then slow down scans to evade firewalls and intrusion detection systems. So we're going to be taking a look at a lot of techniques in this video, and I'll just highlight them right now so that again we have a bit of order. And in the description section, there should be timestamps to each of these topics that we'll be covering. So the first topic we'll be looking at is going to be, of course, timing templates. Number 2, we'll be taking a look at parallelism. Number 3, we'll take a look at the various host group sizes we can customize. Number 4, we'll take a look at host timeouts. Number 5, we'll take a look at scan delays. And 6, we'll end off by taking a look at the packet rate and how to customize the minimum and maximum packet rate you can send or you'll be using when performing a scan. So let's get started with timing templates, right? So timing templates are used to run scans faster or slower based on your target or the working environment that you're in. Now, the timing templates range from T0 to T5, 0 being the slowest and 5 being the fastest. So this is something that, again, you'll grasp really quickly. So if I'm running a scan and I want to run an extremely slow scan, I would start off with T0, right? If I wanted to run the fastest scan, I can run it with T5. Now, the great thing about these timing templates is they have names. So T0, or we can just specify it by typing in T0 here, that has a name of, or the name of this timing template is paranoid. So I'll be posting the write-up of this particular video. You can find it in the description section or on HackerSploit.org. It will actually have a table where it explains in detail what changes with these timing templates and the values that change and how they change, right? So when you're talking about T0, this is the slowest type of scan, and it really isn't used that much unless you're dealing with a very, very specific type of environment. When we talk about T1, the name for the T1 timing template is sneaky. Now, sneaky is primarily used to evade intrusion detection systems. It's a very, very useful type of timing template. And again, the values that get changed are things like the scan delay is reduced to about 15 seconds. And then, of course, the parallelism is still set to serial. You're really not using any type of parallel operations here. So that's T1. When you talk about T2, T2 has the name of polite. So again, T2 again is not really used primarily because it's in between T1 and T3. Now, when you talk about T3, T3 is known as the normal timing template, and the reason it's known as the normal timing template is because this is the default timing template that Nmap runs. So for example, if I run a default Nmap scan on nmap.scanme.org, and again, this is a default Nmap scan, the default timing template that will be used is going to be T3, which again stands for normal. You then have T4, which is an aggressive scan, again T4, and this is the one that is most commonly used when you want to speed up your scan or you want to get your results much quicker. You then have T5, which again is used on networks and hosts that can actually handle this type of scan because it's extremely aggressive. Like when I say it's aggressive, I mean this is an extremely aggressive scan, so you want to use it cautiously. All right, so again, just to highlight over that, T0 stands for paranoid, T1 is the sneaky scan, T2 is the polite scan, T3 is normal, T4 is aggressive, and T5 is known as the insane scan. All right, so I can actually demonstrate this right now. Now, of course, when talking about these slower types of scans, they're going to take a while. So what I'm going to do, if I run a simple scan like Nmap, we'll use a stealth scan and we'll specify a port range of maybe port 21 to port 80. Well, you know, so something extremely simple and customized. To specify the timing template, we'll start off with the slowest template, or we'll use T1, and then I'll use T4 or T5 to actually contrast and show you the difference here. So we'll use nmap.scanme.org, and I'm just going to hit enter now, and we'll hit enter. And again, this is an extremely slow scan and is, as I said, primarily used when you're dealing with rate limiting or an intrusion detection system. So I'll just wait for this scan to complete. I don't think I'll actually even be able to wait because, you know, of how slow it is, and that's primarily why I specified my that is primarily why I specified a very customized, very short type of scan. What we can do is we can actually just customize this, and I'll just say don't ping, right? So we'll skip, you know, host discovery, and let's see whether this speeds up the scan. Again, I'm just going to be using this for demonstration purposes, and then we'll talk about the faster timing templates like T4 and T5. And as I said, we'll be posting a table in the description section or on our website at HackerSploit.org that will actually explain what is happening exactly and what changes with each of these timing templates, what values are changed. And most of these values will actually be covering, especially when you're talking about stuff like host delays, etc. So again, you can see that this is taking quite a while. The more information I try and get on the screen, you can see it tells me that it's still about 0.83% done, which again makes sense. And so again, I'll just hit enter, and this is going to take a while. It tells me it's going to take about 45 minutes. So you get the idea. This scan will take a while and is extremely stealthy. Now, if we increase this to something like T4, you'll actually see the difference in front of yourself right now. So again, you see it's about 13.33% done. 23, 94, 99, and it's done. It completed that in about 7.55 seconds, and that is much faster than 45 minutes. But again, these timing templates are designed to be used under different scenarios. Now, if we use the insane timing template, you'll actually see there isn't going to be much of a difference between T4 and T5. So if I just demonstrate this to you, you can see if we run T5, it's going to run it in 3.67, whereas T4 run it 7.55. So really not much of a big difference. If we run the default scan, which again is going to be T3, I can just hit enter. Again, the difference will really not be that, the differences will be trivial. However, when you're running a larger type of scan, that's where you're actually going to find a majority of the difference. And these scans are used for, again, for when you want to get your results extremely quickly and you know the type of environment you're dealing with. So you can see for the normal timing template, it's about 12.16 seconds. For T4, we have 7.55, and for T5, about 3.67. So again, this pretty much explains the differences. And again, as I said, the lower the timing template, the slower the scan, and the more useful it is for evading intrusion detection systems and any rate limiting systems that might be in place. Great. Now that we've taken a look at timing templates, let's take a look at parallelism. Now, parallelism is a really simple concept to understand. You're essentially Nmap, when you run an Nmap scan, depending on the type of scan you're running and the network environment you're running it on, Nmap will by default set up a minimum or maximum amount of parallel operations that are currently running during a scan, and this helps you increase or to speed up your scan, and again reduce or slow down your scan. So when we talk about parallelism and timing templates and the interrelationship, again, with a slower timing template, the minimum or the maximum parallelism would be set to a lower value, and then with the higher one, the minimum would be set to a higher value. So I'll explain that right now. So as I said, parallelism is used to specify the amount of parallel scanning processes that are being run during a scan. So again, we can do this. So if I run a simple scan like Nmap, and we'll run a syn scan here. Again, we'll just run the previous example, port 21 to port 443, and we want to specify the minimum amount of parallel sessions we want running. So minimum, then we say parallelism, and we then specify the value. So the minimum amount of parallel operations we want running during this scan. So again, the higher the amount of the minimum parallels operations you want running, the faster the scan. So if we set this to 30 and I hit enter, parallelism, I just hit enter. Looks all right. We need to specify our target. Apologies for that. So nmap.scanme.org, and I hit enter. We'll just wait for this to complete. So we've set the minimum amount of parallel operations to 30. So that'll again speed up the scan. That again took about 7.03 seconds. If we now change this to something like 50, again, that'll set now the parallel operations to 50. You can see that this will perform the scan much faster. And there you are, about 2.64 seconds. Now, you can see some very interesting results here. And this is why I actually wanted to cover this, or to actually highlight this area specifically. When you increase the speed of your scan or the aggressiveness of your scan, the results you will get will be most likely unreliable. So you want to be really careful with the options you specify in terms of the timing templates and the parallelism, right? So if I use a reasonable amount of parallel operations like 10, I'll be guaranteed to get accurate results. It'll take a few seconds more, of course, but I'll get, the results that I'm looking for. So in this case, you can see it took about 7.88 seconds, but I get accurate results, and I'm very confident in the results that I get. Now, when we talk about parallelism, you can also specify maximum parallelism, which again, this is very useful, because when you talk about maximum parallelism, this is now where you can really you can structure your scan or fine-tune your scan in environments that have intrusion detection systems, or if your target has rate limiting. This is very helpful. So again, we just change this for maximum. So we say max parallelism, and we can set this to something maybe like 1. And this is again very useful for evasion and stuff like that. So again, if I use 1 and hit enter, it's going to take a while. Again, this might be similar to your timing template, but again, if we hit enter, you can see it's taking its own time. But with this, we're guaranteed to evade any systems in place, any intrusion detection systems in place, and secondly, we are guaranteed that we'll get reliable scan results. So again, I'm really not going to go to go through this scan, because it's going to take a while. However, if I change this to something something reasonable like 5. And I hit enter, and again, you can see it gives you a summary of how much time this is going to take. And again, based on the type of scan you're performing, you can fine tune this to exactly what you want and what you feel is comfortable and what you feel is appropriate. So again, I'm not going to go through this entire scan, mainly because they're going to take a lot of time. I just wanted to explain that. So you want to be really careful with the parameters you specify when talking about your minimum parallelism. Now, by default, Nmap will automatically determine the amount of parallel operations to run based on the type of scan you're running and the network operations. So if you're really not sure about what to run, I don't recommend specifying parallelism unless you're sure of what you're doing, the environment you're dealing with, and the host or the target you're dealing with. So that is parallelism in a nutshell. Now, let's talk about host group sizes. Now, when you talk about host group sizes, that may sound like a really vague idea, but what we're dealing with here, and the scenario we need to actually set up before we get started with specifying the host group sizes is, let's say we're performing a scan, a host discovery scan on a large network, or on an entire subnet, or on a class B network, right? These scans, based on the type of scan we're performing, will take a lot of time, right? And I just want to set up this premise because the next few techniques will be tailored towards these type of scans. So you can customize the minimum and maximum host group size when performing large scans that involve entire subnets or class B networks. So the host group size allows you to specify how many hosts you want to scan simultaneously. So let's take a simple example. Let's say I'm saying Nmap, SS for a SYN scan, and we use the fast option here to scan only 100 ports. I can then specify if let's say we were scanning my entire subnet of 192.168.1.1/24, and this is a large network, right? And the type of scan we're running is stealthy and is going to be relatively fast, but I can specify the minimum host group. So that is specified by typing in host group. I can set this and I can specify the amount of hosts, the minimum amount of hosts I want Nmap to scan simultaneously. So if I say I want Nmap to scan 30 hosts simultaneously, and that's the minimum value, and then I hit enter, this will be significantly faster than if I were to scan only 5. Now again, as I said, you need to be careful with aggressive scans, because you may get you may get incredibly irregular or inaccurate results, and that's because you're changing a lot of default values that again you might be giving you inaccurate results. So again, in this case, you can see it's going through the entire subnet here, and it's going through all the devices. And in this case, it's telling us, it's giving us the results we're looking for. It tells us, this IP is filtered, etc., and it's still going through the scan. And it's about to hit the limit here. It's about 255 IPs. So we're just going to let this run. And then again, I'll compare it to something like, or I'll use the maximum host group option, which again will allow you to slow down or fine tune your scan. So you can see in this case, it tells us, and this is the problem here, that Nmap is done, and we have about 256 IP addresses scanned. 256 of them are up, which again, you can see it tells me for all of the IPs, they're all filtered. But again, for some here, if I scroll the way down, 1 second, let me just go to the top here. You can see that it gives me a few accurate pieces of information. But if I set the minimum host group to something like 10 or something reasonable, then again, I can get more accurate results. Now, when we talk about, the maximum host group option, this again is used when you're really dealing with various constraints on a network, or you want to fine tune your scan to be as accurate as possible. So I can say the maximum host group size, I can set it to about 5, right? And I'll hit enter. And this hopefully will give me much more accurate results. So again, you can see it's now taking its time in regards to the host discovery. So there we are, it's still running, and it's still going to give us a fair bit of information here. In any case, I'm not going to go through with the scan, because again, I'm just using this for demonstration. So you can specify the minimum and the maximum host group size. And again, this is used when scanning large networks, or when you're dealing with subnets. Now let's talk about an interesting technique that I personally really love demonstrating, and that is the host timeout, right? So when you're talking about your host timeout, this is used to specify the amount of time to elapse when scanning a target before skipping the host. So let's say you're scanning a large network, or you're dealing with a subnet or a class B network, right? And one of the issues that you'll typically run into is that a host will not respond, right? So Nmap will send a packet, but this device, for some reason, will take time to respond to that packet. And in the event it doesn't respond, or the device is offline, Nmap has essentially wasted that time waiting for that device to respond. Now, this, of course, can cause issues if you're dealing with a network that is extremely slow, you're dealing with rate limiting, stuff like that. So this is where the host timeout option comes into place. This allows you to, again, specify a timeout period under which, if a target does not respond, Nmap skips it. And as I said, this is very useful when scanning large networks. So what we can do is we can run a very default scan here. So I'll say, Nmap. And we'll then say, we want to skip host discovery. Let's say I'm performing an extremely comprehensive scan on my network, and I can run, I want to perform the scan. I want all ports to be scanned, all 65,535 ports. and I want to run this on my entire network, both class B and C. So I say 192.168.1 to 55.1 to 55. So, you know, both class B and class C. This is a huge scan. Now, as I said, the problem or the issues that you'll commonly be dealing with is some hosts will take a while to respond or maybe appear to be stuck based on various factors. As I said, like the connection might be flaky. The problem is Nmap will wait for the target to respond, and then of course if you analyze the packets, again Nmap will wait for response. If there isn't a response, it'll wait, and that will slow down the scan. So if you want to increase the speed of your scan, you can set the host timeout to whatever value you feel is appropriate. So host timeout, and I can set this to something like maybe 30 seconds. So what this means is if a target or a device on the network does not respond within 30 seconds, skip it. Now, this again can cause really inaccurate, or can give you really inaccurate results, because you need to be careful in regards to the amount of time you provide for your host timeout, because a device may take even 2 minutes to respond, and just because you skipped it does not mean it's offline. So you want to be very careful with this. So I hit enter, and again that tells this scan will wait for 30 seconds. If a host does not respond within 30 seconds, it moves on to the next one, regardless of whether or not it's offline. So again, this scan is extremely huge. I'm performing a scan on a lot of addresses here, on both class B and C. And again, these are the types of scans that you'll be performing, when you're dealing with large subnets, and you really need to know what you're doing regarding, the type of responses you'll be dealing with. So what I can do to just demonstrate that I can also make the scan run even faster is, let's say I specify the host timeout to 5 seconds, which this is an incredibly inaccurate type of scan to run, but I'm trying to prove a point here. So again, that means if a host does not respond within 5 seconds, you can see how fast this is. So immediately I'm being told 192.168.1.1 is up, 1.2 is up, 1.3 is up. Sorry, 1.2 was skipped. Sorry, my bad. Only one, I believe. Yeah, you can see we're actually getting quite a few inaccurate results. But 192.168.1.4 is up, etc. But you can see we're getting inaccurate results, and that's because we're really not giving Nmap enough time, or we're not giving the hosts enough time to respond. And then based on that, Nmap says, hey, if you don't respond within 5 seconds, I'm going to move on to the next host. So that is how to specify your host timeout. Again, you need to be very careful with these options, because they can greatly impact the accuracy of your scans. Now let's talk about scan delays. Scan delays is very simple to your host timeout, right? So your scan delay allows you to pause Nmap for a specific amount of time between each probe or request that you send. This is great when you're dealing with rate limiting firewalls or intrusion detection systems. So I'll demonstrate this. It's very simple. So let's say I run a TCP connect scan, or we will actually I want to specify the amount of time Nmap will have to wait between each probe. So before sending each probe. So I say Nmap, this is a simple TCP connect scan, and then I specify the scan delay. I say the scan delay, I want to set that to maybe 10 seconds, right? Or I can just say 5 seconds. And I then type in our target, so nmap.scanme.org, and I can use a tool like Wireshark to show you this, and it really is very cool. So I'll start the capture and I'll hit enter, and what you'll see is Nmap will wait for 5 seconds, and then we'll send because this is a TCP connect scan. You're going to see that we have the SYN scan being sent here, and then after 5 seconds we get the other SYN being sent, and then after another 5 seconds you get the other SYN being sent, right? And we're still waiting for the SYN-ACK back from the target, and then after another 5 seconds you get the SYN, after another 5 seconds you get the SYN, etc. You get the point. You can actually specify a scan delay time or scan delay period. So if I specify something like 10 seconds, I'll actually show you that right now. you'll be able to actually visualize this yourself. So I'll start the capture and I'll start the scan. We'll wait for 10 seconds. There we are, we have the first sin. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and there we are, we have the second sin being sent. So again, you can time this yourself, and Nmap is extremely accurate with that, but again, depending on your network conditions, you want to give it 1 or 2 seconds, plus or minus. So that is how to specify your scan delay, and you can see this is very useful because if you're dealing with an environment or a target that is actively monitoring traffic, right, and you want to be as clandestine as possible, you can reduce it to something like 30 seconds. Now, of course, the scan will take a lot of time, but you'll not be alerting any intrusion detection systems. So that is scan delays, and we move on to our final technique, which is the packet rate. So the packet rate is a technique that is used quite a bit, and again, this option allows you to specify the minimum and maximum amount of packets you want to send per second. So that sounds exciting, right? So if we say Nmap, we run a simple TCP connect scan, and we can then specify the minimum rate of packets we want to send per second. So let's say I want to send 20 packets per second. We say nmap.scanme.org, and we hit enter. That's going to send about 20 packets per second, and we can start a new capture, and let's see whether this is indeed accurate. So I'll hit enter, and there you are. You can see this is extremely aggressive type of scan, and this is the type of stuff that alerts intrusion detection systems. So there you go, about 20 packets per second. I can't even track how much it's sent already, but again, it's an extremely fast scan. And yeah, you can actually use this to speed up your scan. You want to be very careful with that, as I said, and the scan is complete. You can see because of the aggressiveness of the scan, I wasn't able to get any results. So if I changed it to something like, and I use the maximum rate now, I say the maximum rate is maybe like something like 2 seconds or 2 packets per second, which is much more reasonable, right? And I'm just going to start a new capture here. And we'll just hit enter now, and there we are. You can see we're sending about 2 packets per second. There we are, and in this case we might be able to get or we will get more accurate results. Now the scan will take longer, but again we'll get really accurate results. So again, I'll just wait for this scan to complete, and yeah, these are pretty much all the techniques that I wanted to cover. I know I haven't covered all the techniques available when it comes down to scan timing and performance, and again, I've pretty much covered the most important ones. This scan is still running, and yeah, so we'll just wait for it to complete. So again, when talking about faster or aggressive types of scans, I just want to summarize. You want to be really careful because it will affect the accuracy of the results you get. In terms of dealing with networks or devices that really cannot handle that much traffic, you want to use the slower, or you want to slow down your scans. Again, I recommend using timing templates. You make use of parallelism, very important, and also you can specify your packet rate based on the type of scan you're running. So we'll just wait for this scan to complete. It's going to take a while because we're only limiting it to about 2 packets per second. So I'm just going to end this scan here. That's going to be it for this video. Thank you very much for watching. If you found value in this video, please leave a like down below. It really helps the YouTube algorithm, put our videos in front of the right people. If you have any question, please post it in the comment section, or you can hit us up on our social networks on Twitter at HackerSploit. A write-up of this particular video is going to be available on our website at HackerSploit.org, and you can join in the discussion on our forum at HackerSploit.org or at forum.hackersploit.org, and I'm going to be seeing you in the next video.